Hi guys, in this video I would like to talk about the ratio test and the root test. The ratio test is on the AP exam, so this one is on the AP exam this year, and the root test is not on the AP exam. The first thing I'd like to do before we get started is make sure that we know how to simplify some of these expressions. Let's look at the top expression here, A. If I have n factorial over n plus 1 factorial, how can I simplify that? Remember, n plus 1 factorial is really n plus 1 times n factorial, because you always just take each term down by 1 for the next factor. All right, this one right here is n factorial, so this one simplifies out to be 1 over n plus 1. All right, what about expression B here? The numerator here is really n plus 2 times n plus 1 factorial over the denominator here is really n plus 1 factorial, and so this simplifies right here to 1. So my answer is n plus 2. Okay, finally, a problem like this one right here. One way to do this is actually to say 3 to the n plus 1 is really 3 to the n times 3 to the 1, right? Because when you multiply things with the same bases, you add the exponents. And the denominator here is 3 to the n. So what this really is, if I simplify, it's really 3. Okay, another way to say that is this is really just, if you're dividing expressions with the same base but different exponents, you subtract the exponents. So another way to say this is really 3 to the n plus 1 minus this bottom exponent, which is n, and so I get 3 to the 1, which is 3. Okay, let's look at these two problems here. If I know that f of n is equal to n plus 2, then what is f of n plus 1? If I know f of n is equal to n plus 2, f of n plus 1 means everywhere there's an n, I replace it with n plus 1. So this answer here is n plus 1 plus 2, which is n plus 3. What about this problem here, letter B? If I want to replace n with n plus 1, what do I get here? I get 2 times the quantity n plus 1, which is equal to 2n plus 2. So be careful here, because students think that when you replace the n with n plus 1, you always just add 1, and that's not true. Up here, it was the equivalent of adding 1, but down here, if you had just said this answer was 2n plus 1, that would have been incorrect. All right, let's move to your notes. Your notes, we talk about the ratio and root test, and let's start with the ratio test first. What does the ratio test say? It says that if you have a series, okay, if you take this n and you replace it with n plus 1, and you divide it by the original expression a sub n, you take the limit of the absolute value of that, and absolute value means don't worry about the signs. Then if this expression is less than 1, then the series will converge. If this expression is greater than 1, then the series will diverge. Now what's super important is to understand that if this expression is equal to 1, the ratio test doesn't work, and so you have to use another test. All right, let's look at the first problem here. It says, see if this series, this A series here, converges or diverges. We're going to use a ratio test. When do you know to use a ratio test? A lot of times when you have exponents and factorials, when the problem looks kind of complicated, like this problem looks pretty complicated. All right, exponents and factorials, ratio test is probably a good way to go. All right, how do you do the ratio test? You take the limit as n goes to infinity of your a sub n plus 1. So everywhere there's an n, you're going to replace it with n plus 1. So this will be 2n plus 1 over n plus 1 factorial. And then you're going to divide that by a to the n. So this will be, this is your original a to the n. Anywhere there's an n, you put in an n. So that's 2n over n factorial. The absolute value of that, okay? If you take the limit of this, okay, if this limit is less than 1, the series will converge. If this limit is greater than 1, the series will diverge. If this limit is equal to 1, that means you need to try another test. So let's look at this. How do I take the limit of this expression? Well, it looks pretty complicated. So what I'm going to do is try to get rid of this fraction over a fraction. To do that, I say dividing fractions easy as pie, flip the second, and multiply. And this is still an absolute value here. This is equal to the limit as n goes to infinity of, remember this 2n plus 1 is really the same as 2n times 2. N plus 1 factorial, if I want to cancel out with this n factorial, actually with ratio tests, a lot of things usually cancel out. I'll just take this down by 1. So this will be n plus 1 times n factorial. This will be times n factorial over 2 raised to the n. And look at what cancels out. The 2n cancels with this 2n. They cancel out to 1. They don't just disappear. The n factorials cancel out. So what I have left is a limit as n goes to infinity of 2 over n plus 1. And what is the answer to that? There's really an absolute value here. As n gets bigger and bigger and bigger, this will go to 0. Compare this number to 1. It's less than 1. So therefore, this series converges by ratio test. Let's look at letter B. Letter B has this expression here. I'm going to implement the ratio test on it. To do that, what I do is I take the limit as n goes to infinity of the absolute value of, I take the every n and I replace it with n plus 1. So this becomes the quantity n plus 1 squared, 3 times n plus 1 divided by 2n plus 1. And then I'm going to divide this whole a to the n plus 1 expression, this whole a to the n plus 1 expression by a to the n. And a to the n is just rewriting the original problem that I had. Alright, so all I need to do is take the limit of this. The first thing I'm going to do is try to avoid fraction over fractions. So I'm going to take the limit as n goes to infinity of n plus 1 squared, 3 to the n, this is plus 2 now, over 2 to the n plus 1, times, dividing fractions easy as pie, flip the second, and multiply. Alright, now it looks a little bit simpler. When I get it into just one fraction form rather than a fraction over a fraction, what I'm going to do is try to simplify things as much as I can. So I'm going to rewrite this. This is n plus 1, the quantity n plus 1 squared. This is really the same as 3n times 3 squared over, remember this right here is really the same as 2n times 2, 2 to the 1. Over here I have 2 to the n over n squared times 3 to the n, and this is really 3 to the n times 3. Alright, so let's see what cancels out here. The 2 to the n cancel out to 1, the 3 to the n's cancel out to 1. This is 3 squared and this is 3, so this is going to cancel out to 3. Alright, so I think I've canceled out as much as I can. So let me see what the answer is here. This will be the limit as n goes to infinity of, I still have the n plus 1 quantity squared on the top. I've got a 2 times n squared on the bottom. I've also got a 3 here on the top, so there's a 3 here. This is the absolute value of this. Okay, the question is, what is the absolute value of this? Well, let's think about it. I don't know if you see this, but this 3/2 here is really kind of a scalar. Okay, you could pull it out if you want to. So what I really want to do is take the limit as n goes to infinity of this n plus 1 quantity squared over n squared. All right, and this really is an absolute value. All right, what is the limit as n goes to infinity of n plus 1 quantity squared over n squared? Well, the leading term here is n squared, right? And the leading term here is n squared. So it's really just the ratio of the coefficients. So this is really 3/2 times, if you think about it, this is really n squared plus 2n plus 1. But these numbers here didn't really matter. You just take the leading terms. So the answer is 3/2 times 1, which is just 3/2. You compare this number to 1. 3/2 is actually greater than 1, so therefore this series will diverge by ratio test. All right? Okay, let's look at the last problem here for ratio test. So this will be the limit as n goes to infinity of, everywhere there's an n, I'm going to replace it with n plus 1. So that's going to be n plus 1 plus 1, which will be n plus 2 factorial over 3 to the n plus 1. I'm going to divide that by a sub n, which is dividing it by itself. So that's n plus 1 factorial over 3 raised to the n. And I'm going to figure out what this limit is. This looks very complicated because it's a fraction over a fraction. So let me see if I can get rid of that. This is going to be n plus 2 factorial over, and I'll go ahead and split this up into 3n times 3 times, dividing fractions easy as pie, flip the second and multiply. All right, and this is a little bit simpler, and what I'd like to do here is actually try to simplify as much as I can. I can see that this n plus 2, if I change it, I can actually simplify it with this n plus 1. Because remember, n plus 2 factorial is really the same as n plus 2 times n plus 1 factorial. All right, so what simplifies here? The 3n reduced to 1. The n plus 1 factorials cancel out. So what I have is a limit as n goes to infinity of n plus 2 over 3. And as n gets bigger and bigger and bigger, this expression is going to go to infinity. When I get the answer, I compare that with 1. Infinity is bigger than 1. So therefore, this series will diverge by ratio test. Let's look at root test. Root test is not on the AP exam. It's really an easy test to do. What root test says is that if you find the root of an expression and you take the limit of its absolute value, then if that expression is less than 1, the series will converge. If that expression is greater than 1, then the series will diverge. And if that expression is equal to 1, then you need to try another test. This looks a lot harder than when you really do the root test. So let's look at the first problem. What you want to do with the root test is find that things are raised to the nth power. Okay, so I'm going to change this to e squared over n raised to the nth power. Okay, and the root test says if I take this root, okay, so I take the root of the nth root of this, and if I take the nth root of this, then I get this root back. So I take the limit as n goes to infinity of this root here, so that's going to be e squared n, okay, and n gets bigger and bigger and bigger. What this number will go to is 0. Then I compare this answer 0 with 1. This is less than 1, so therefore this series will converge by root test. All right, so root test actually, if you think about it, is a lot like the geometric series test. It's just that the geometric series test doesn't allow you to have an n in here, all right, but the root test does. So let's look at another example for root test. Root test says if you have something that is raised to the nth power, okay, then all you need to do is take the limit as n goes to infinity of that something, okay, so of that 3n plus 4 over 2n, this is the absolute value of that, okay, this is equal to, the limit of this is actually 3/2, right, and you compare that to 1, this is greater than 1, so therefore this series will diverge by root test. If you look at your homework, you have some ratio test examples, okay? And then you have a worksheet that has a combination of every single test that we've talked about. And if it has a star by it, then that problem is not on the AP exam. But if you've been following along with all the videos, you should be able to do all of the tests except for integral tests. The hard part of this is figuring out which test to use, trying to figure out which test will work. But again, if this has a star, then it's not an AP test. You can skip it. If you'd like to challenge yourself, then do all the problems with the star and without the star. And the key is attached. Good luck.